Now that we've written some expressions and simplified some expressions, we can turn symbolic expressions, or expressions containing variables, into concrete numbers in what we call evaluating an expression. So an expression like 2x plus 4y might not be all that useful to you unless you have specific values for x and y. Otherwise, you can't evaluate or get a value for the expression. So to evaluate an algebraic expression, we first need specific values for each of the variables. Then we substitute those values in for the corresponding variables in the expression and do some arithmetic to get a value for the expression. So this shouldn't be all that difficult. All we're doing is plugging in the value we're given, or replacing or substituting. I'll use those terms all interchangeably, but anyways, we're plugging in a value for a variable, an expression, and the rest is just arithmetic. So that's all there is to it. I've already done a lot of these in the past, and you've been exposed to it. So this shouldn't be anything too foreign for you guys. So let's do some examples. First one, 2x minus 7 and we're setting x equal to -3. So here we're given an expression 2x minus 7 with a variable x, and here it's telling us what x is equal to in this specific situation. So we simply replace the x in the expression with -3. So we take 2 times -3 minus 7. 2 times -3 is -6 minus 7, -13. So -13 is the value of this expression when x equals -3. Moving on. 2x plus 4y, and we're setting x equal to 10 and y equal to 6. So here we've got two variables, and thus we're given a value for each of the variables, x equals 10 and y equals 6. So basically we do the same thing here. So we're going to substitute 10 in for x and y equals 6. 2 times x is 10 plus 4 times y is 6. So just multiply. 2 times 10 is 20. Plus 4 times 6 is 24, and add 20 plus 24 is 44. So when we have x equal to 10 and y equal to 6, the value we're going to get for our expression is 44. Simple enough. So I hope you guys are finding this pretty easy, at least the procedure of substituting a number in for a variable. But what are we really doing when we evaluate an expression? That's what I really want you guys to get out of this video, to understand at a conceptual level what's really going on when you're evaluating expressions. So if you'll remember, the expression we had here, 2x plus 4y, was an expression I used on a previous video, and we said it represents, I'll rewrite it down here to give us some more space, 2x plus 4y, and we said this expression represents how much a family will pay for tickets at the movie theater. So I'll refresh your memory, or if you didn't watch this video, I'll give you the gist of it. We had 2 adults and 4 children in a family, and the price per ticket at a movie theater is different depending on whether you're an adult or a child. So for an adult, the price is X dollars for a ticket, and for a child, the price is Y dollars for a ticket. So we said if we take 2 times X, which is the total amount the adults in the family pay, and we take 4 times Y, which is the total amount the children pay, if we add those together, that should get the total amount the family pays. So here, when we're evaluating this expression, we're trying to find the total price in the situation where the adult's price is 10 and the child's price is 6. right? Because that's the numbers we had there. X equals 10, which was the price for adults, and Y equals 6, the price for children. And we found that to be 44. So the total price the family would pay would be 44. Having a general expression like 2x plus 4y allows us to find a value for any combination of ticket prices x and y. So we could have, like I said, any combination of x and y. Well, I guess as long as they're positive, you can't have negative ticket prices. So let's say instead of x equals 10 and y equals 6, that's what we had, we could say x equals $12 and y equals $8. Then simply we'd plug those values in. So 2 times $12 plus 4 times $8. 2 times $12 is $24 plus 4 times $8 is $32. 24 plus 32 is $56. So that's how much the family would pay in that situation. So the power with algebra and variables is being able to have one general expression to cover all possible situations, in this case adult and children ticket prices, but we also want to find a specific value for a specific situation. That's where evaluating expression comes in. So evaluating takes us from a general expression like this to a specific value like that. So I hope this is making sense to you guys. It will become more clear with some more examples. So let's do another one. Now this one has some words and it's a problem with the formula. So here it says the formula for the area of a trapezoid is given by the expression 1/2 times h times the quantity a plus b. And you'll see this is our trapezoid over here, and h is just the height of this trapezoid, and a and b are the lengths of the opposite parallel sides. And we're being asked to find the area of the trapezoid when h equals 6, a equals 4, and b equals 8. So you'll see this fairly often. In a couple of videos back, we did one with area of a rectangle where we had width times length. So formulas will often have multiple variables, and you can plug in values for those variables to find, well, in this case we're finding the area. That's what this formula is for. So we're going to plug in these values here for the respective variables in the expression, and it should give us the area. Okay, I'll do this here. 1/2 times h is 6 times the quantity a is 4, and we're looking for b, that's 8. Now we solve inside the parentheses. 4 plus 8 is 12. Now it's multiplication. 1/2 times 6 is 6 divided by 2, or 3 times 12. That's just 36. So when we have h equals the height is 6 and the length of the opposite sides, opposite parallel sides, 4 and 8, that should give us an area of 36 for that trapezoid. So, but what's important to remember is that the area of a trapezoid is always 1/2 times h times the quantity a plus b. Now it's not important that you remember the specific formula, but what's important is that this formula is general and covers all values of h, a, and b, but this formula does not give us any areas unless we have specific values for those variables and evaluate the expression with those values. Last one here. So we have 1x plus the quantity x minus 5 squared plus the quantity y plus 2 squared. And we're setting x equal to 3 and y equals 1. Okay, so here we've got some exponents and division, but this just is more a test of your arithmetic than anything else. So we're going to plug x in, or 3 in for x, and y in, or excuse me, 1 in for y, 3 in for x, and 1 in for y in this expression. So 1 over 3 plus x is again 3 minus 5, squared that, and add that to y is 1 plus 2 squared. Order of operations, we'll take care of parentheses first. 3 minus 5 is negative 2, square that, plus 1 plus 2 is 3 squared. Now we've got exponents. Negative 2 squared, remember a negative squared is a positive because we're taking a negative times itself, which is a negative, so a negative times a negative is a positive. So negative 2 squared are negative 2 times negative 2 is positive 4, and 3 squared is 3 times 3, or 9. Okay, we have a fraction here, so it's going to be a little bit of a little more work for us, but we have a denominator of 3 here, and these guys, remember, have denominators of 1, since anything divided by 1 is just that same value. So we have to get it so where we have the denominator on all the terms is 3 before we can add these together. So how are we going to do that? Well, we need to get 4 and 9 to have a denominator of 3, and we can do that by multiplying by a form of 1, right? Because we don't want to change the value of 4. We can't just put in some arbitrary value that has a denominator of 3. We want to keep the value the same. To do that, I'll put the 1 there too if you like. So we're taking 4 over 1, and we want to multiply the denominator by 3, since we're going to multiply the numerators together, denominators together. So we'll multiply the denominator by 3, but we want to keep it equal to 1, so we put a 3 up there. So we're really multiplying 4 times 1 here, but that's going to give us a denominator of 12. So 4 times 3 will be 12 over 3. Do the same thing for 9. That's 3 over 3 there. 9 times 3 is 27. 1 times 3 is 3. I'll scroll down a little more. So now we just plug in these values, 12 over 3 and 27 over 3, back in for 4 and 9. So we get 1/3 plus 12/3 plus 9/3. Simply add together the numerators and keep the denominator the same. So that's going to give us 1 plus, or excuse me, that last term should be 27 over 3. So now we add the numerators like I said. 1 plus 12 is 13 plus 27 over 3. And that's just 13 plus 27 is 40 over 3. So that's the value of our expression there, 40 over 3, when, what did we have here? X equals 3 and y equals 1. So that's our value, 40 over 3. Good review of fractions there. So that's all I have for this video. In the next video, why don't we wrap up algebraic expressions by going through all the stuff we've learned. I'll give you guys a problem, and we'll write, simplify, and evaluate an expression for that problem. So I'll see you guys next time.